All right, welcome back. This is Lecture 1, a zero index for Computer Science E-75. It's a bit of a stilted start, of course, because we haven't been here for 2 weeks' time. But today we really start to dive in. You will see posted by tonight or by morning will be the specification, the PDF, for Project Zero, which I can spoil the surprise because we already did 2 weeks ago, essentially. This will involve buying your own domain name if you don't have one already. You can get away with a $3.99 one, $9.99. You can get something like .tv for $29.99. It's really up to you, but if you already have your own domain name, that's totally fine. What you'll see in the specification is that whether you own a domain name already or buy a new one for the course, you will ultimately configure one or more DNS settings with your internet registrar that will effectively map a subdomain in your domain, www.foo.com or harvard.foo.com, whatever subdomain you choose. You will create, as we discussed 2 weeks ago, a record called a CNAME for your own subdomain that will make it resolve to cloud.cs75.net. So we will be operating essentially as the web hosting company like we discussed a couple of weeks ago. Once you tell us this information by submitting Project Zero online, which will amount to a few demographic questions, some background, some technical questions about your domain name, we will then run some commands on our server, create some of the virtual host entries that we'll look at today so that our server then knows if it ever sees a request off the internet for www.foo.com and you own foo.com, we will then map that request to your own home directory on this so-called cloud server. So as part of this process, you'll end up getting a username and a password on the cluster. For the most part, you can develop your projects offline on your own computers, even on some other server. But again, they will ultimately need to be uploaded to and live on the so-called cloud, albeit in your domain name. And we'll have separate subdirectories essentially for each project, so you'll keep things nicely organized. And then at the end of the semester, if you are quite proud of something you produce, particularly your final project, we'll make for an easy transition to moving that code to a web host or your own server. You'll find that everything is very much industry standard. So more on that in the PDF when you wake up in the morning. Any questions about this? No? Or at least when I wake up in the morning. Yeah.
So we don't purchase any hosting from
No.
the domain. We just buy the domain name.
Correct. You do not need to buy hosting. In fact, you shouldn't really, certainly for the course's purposes, because we'll need to host the site so that we can have access to everything. It's going to be just the domain name. And then if you have as you'll see in the spec, if you have no familiarity with domain registrars, frankly, I would just go with GoDaddy, if only because the staff can then tell you exactly what to click, where, and so forth. And they are one of the biggest, so you're not going for some fly-by-night operation. If you do pick the cheapest possible place you can find online, just be sure that you can do with them what's expected in the spec, namely creating a CNAME entry that maps something.yourdomain.com to cloud.cs75.net. Odds are they do this, but if they don't, you might want to spend more than the $2 domain name that you actually got. So. All right. Well, without further ado, today is ultimately about PHP and building the first of our dynamic websites. You'll find that because the course assumes prior programming backgrounds, we won't dwell so much on the concepts in this language since they are pretty much common to most any high-level language. So we'll take for granted you know what a loop is and functions and the like. I'll introduce the jargon that happens to be PHP specific, but we'll focus in particular on some of the features of this language and some of the conceptual aspects of PHP and using it in a web environment so that you can begin to now use this to craft your own projects. But first, we need a place to put these projects. And these projects are going to live on a web server. That web server is going to be accessible via something called HTTP. And as a quick refresher, what was, 2 weeks ago, HTTP? Okay, so it's a protocol. And what does that mean in layman's terms? Yeah, so it's a series of conventions, much like humans walk up to another, extend a hand, shake hand. That's a protocol whereby both parties know in advance how to interact with the other. Well, same deal with HTTP. When a browser pulls up something.com, it sends what's called an HTTP request, and we sniffed this traffic using Firefox last time, one of those free plugins, and specifically it sent a message, among others, but the most important was get, and then the path to the file they want to get, for instance, / for the default root of the website, and then HTTP/1.1 or something like that. So that was the essence of a get message. So if you haven't already, and you'll start to do this certainly with Project 1, not necessarily Project 0, but do go ahead and pull up in Firefox, go to the course's homepage, which has a number of tools under software. Pretty much all of them appear under Firefox add-ons, and if you have not already, I would certainly recommend downloading one or more of these so that you can certainly do it on demand. But recall 2 weeks ago we looked at Firebug, we looked at live HTTP headers, and Web Developer, and the others are useful, although perhaps not as often useful. So let's actually use this thing. Let me go ahead and pull up live HTTP headers again. Click clear there, slide this over. Sometimes stuff goes on in the background, often involving Google it seems. So let's go ahead and go to, how about www.google.com, enter. And now scroll back up, and there is that so-called HTTP message. Of the lines we see up top, that's the request headers that are sent from browser to server. Which ones are actually noteworthy or important, more so than the others, if we're going to render judgment here? What were some of the ones that we highlighted for good reason last week? Or 2 weeks ago, besides the get? Okay, so host. So there's that second line up there. It says host : www.google.com, which would almost feel redundant since I already know I'm going to google.com. I typed it in, I hit enter, and so surely if google.com, the server, is receiving this request, surely it knows who it is. So what role does that line, that reminder, play? CNAMEs. How so?
So it can mask a redirect.
So you can can you be more specific?
So the CNAME could be pointing to something other than google.com.
Okay. So that's quite true. So you could have one fully qualified domain name actually mapping to a synonym of sorts. So that's true. It's not quite as germane here. So let's dig a little deeper with this host line. Because really, it's only the recipient that's going to care about this. So virtual hosting, and herein lies the goal of Project Zero ultimately, is to get everyone up and running on CS75's cloud, albeit all on the same server or cluster of servers, but you're all going to be living specifically at the same IP address, and that's the catch. So the host line is included so that web servers can multiplex among different websites that may all very well live on the same server. In other words, recall last week's story where we focused on browser talking to server, we drew an internet cloud on the board, and a lot of the discussion focused really on some low-level details, like an internet connection using TCP/IP, which uses not so much this human-friendly stuff like www.google.com, but it boils down to IP addresses. The envelope, so to speak, we said that we're going back and forth across the internet, had in the to field an IP, the from field an IP. So the whole idea of a host name or fully qualified domain name, that's inside the envelope. But the catch is when that envelope arrives at a server with an IP address, if there are 10, or in this case 80 different students' websites running on that site, or just commercial websites running on that same server at the same IP, the reason this thing's included inside this envelope is so that the web server can say, okay, obviously this is destined for me because it reached me and my IP on the internet, but specifically what web site am I supposed to check for index.html or equivalent, and it derives that information from there. So we'll see in just a moment a configuration file for Apache, one of the most popular web server tools. We'll do this configuration for you, but if you choose ultimately to dabble on your own computer or to download eventually the course's appliance where you can play with all of this locally, you will see that just takes a couple lines of configuration to inform the server that, hey, this website and this one all live at the same IP. A couple of other lines that were somewhat juicy. Cookie, we'll come back to this in great detail because it's thanks to cookies that you don't have to authenticate on every single page you visit on some website. You can log in once and it somehow remembers that you're logged in. User agent is certainly interesting for statistics or just for logging what browser and operating system people tend to use. And then some of these other details are useful, though lower level. Among the features embedded in those other lines is part of the protocol that says the client should tell the browser if the client knows how to uncompress information. Because a nice optimization on web servers is to gzip or to zip up content, especially HTML content, which is just text, compresses pretty well. If the browser doesn't say, hey, I support compression, well, the server's not necessarily going to do it. So there's a lot of this back and forth, hi, how are you, handshaking that goes on so that browser and server know how to communicate. So that was the live HTTP headers plugin, and we saw something similar with Firebug, different tool, but same capabilities. All right, any questions there? All right, so how do you actually make this happen? Well, Apache is the name of popular web server software. The name of the program itself is generally called HTTPD, as you may eventually see. The D stands for daemon. So if you're ever running your own web server, which we'll do in this case, but you're welcome to do certainly, the name of this program tends to be HTTPD, so they're synonymous. The documentation is omnipresent, but somewhat arcane. So to be honest, when learning this stuff, especially some of the configuration details and features like rewriting URLs that we'll discuss somewhat tonight, frankly, Google tends to be your friend in looking at examples as opposed to the authoritative documentation until you get comfy with it. So just let me plant that seed. But let's take a look at how this actually happens. So one of the course's servers happens to live at the moment at that IP address, 64.131.79.130. The specifics are uninteresting, but the fact that I've mentioned it is useful. So among the capabilities with many web server implementations like Apache is the ability to run, obviously, on a server, but also listen on one IP address or maybe two different IP addresses or multiple different IP addresses. This is not uncommon these days for one server to have multiple network cards or even one network card with multiple IP addresses, often for redundancy purposes. So we'll talk about scalability toward the end of the semester, but consider now the fact that if you've got two web servers that are essentially identical, same files on both of them, and one of them happens to break, well, because of DNS and whatnot, you don't necessarily want 50% of your users still ending up at this dead host. So a nice feature that you can use in the event of disaster recovery is just give this server this guy's IP address so that now this guy is listening on too. But the relevance then is that you have to make sure your web server is actually configured to be listening on multiple IPs. In this case, it's just listening on this one. And the :80, quick refresher. Relevance of the 80?
Port.
So port, and what does that mean? So it's a virtual ID. So the world has come up with some conventions whereby 80 denotes the service called HTTP, 25 denotes mail or SMTP, 22 is SSH, 21 is FTP. So all of these protocols, all of these acronyms that you might have seen over time generally have a number that corresponds to them, and it's the number that the computers actually care about. You don't normally see :80 in a URL because it's assumed to be the default, but the reason for this is that if you go to cs75.net in a browser, well, clearly you want, because of the context, the web page. But we also receive mail. So how does the server distinguish between packets coming in that want web pages versus ones that want mail? Well, included in this virtual envelope that we discussed 2 weeks ago is not just a person's IP and the return IP, but also this port number that says, I want this server and I want this service specifically. We'll talk toward the tail end of the semester about security as well as throughout, but among the topics in security are certainly firewalling and blocking certain types of traffic. So if your company, university, or even home blocks, for instance, certain traffic, that is often the result of blocking specific port numbers. As an aside, as web developers, you'll often see people use like 8000 or 8080 as the port. Why would someone run a web server on a non-standard port, do you think? Security. Okay, so there's something to be said for a little bit of security through obscurity, as they say, whereby you're less likely to get attacked if no one knows where it is. Now, they could guess, but it's a pretty big range, and why bother when there's so many other thousands of web servers they could just hit via their IP address? As an aside, generally the numbers from 0 to 1024, give or take, are reserved, so you really should not use those, but anything between 1024 and 65,000 are up for grabs for people to use. So the range, people have kind of standardized on some port numbers nonetheless over time. So you might do that. For development purposes, it's sometimes useful to run multiple web servers on your own computer that do different things. Sometimes within a company, you might have different port numbers in use so that they can have different tools running on their servers managed by different people. Letting these things leak out into your URLs generally is probably not the best practice. And you see this sometimes. There's various websites I've encountered even recently where all of a sudden I find myself at port :80. And just hard coding that is probably a bad idea, if only for the aesthetics, because odds are people aren't going to move their web server to another port, but there's just no reason, certainly. So as a matter of design, probably not the best thing. So what's this directive here saying? So this is an excerpt from a file called httpd.conf, On some Linux systems, it's called apache.conf or apache2.conf. It's pretty much the same contents. But this is a directive, so to speak. It's just a chunk of code in a big configuration file. And it's kind of XML-like or HTML-like, but then they started cutting corners after that. So it's kind of their own proprietary format. But more on that when we dive into XML in a couple of weeks. But what this is saying is here comes a virtual host. Here comes the definition for one website with one or more names that lives on this server. If there are others, they would be lower or higher in this actual file. So what's important here or interesting? So server name, this is the line of code that we'll create for you that informs the server not only does a web server live at this IP, there is a website called mailinrouge.com. It's a friend's choice of name. He came up with it. I'm not that vain. But I did then buy the domain just to... Anyhow. So server alias. So a common question, or certainly common feature these days, is that a website lives both at foo.com and www.foo.com. That doesn't just magically work. There has to be some configuration involved. Two important things. So one, you need to tell the web server that it should be listening for requests for the host called mailinrouge.com or www.mailinrouge.com. But there's another hugely important configuration detail that needs to be set up for two different names to map to the same server. Where is that configuration done? You can answer this based on tonight and lecture 0. If you're thinking, I don't know. Yeah?
We need a CNAME to map the www.
Good. So, or more generally, you need a DNS record. Might very well be a CNAME record, but you need to configure DNS. You need to inform the world that both foo.com and www.foo.com, or whatever your domain is, actually map to a given IP address. And a CNAME is certainly one way to do this. The root of a domain, so foo.com itself has to be an A record, and that has to map to a specific IP address, for instance, 64. Whatever is up there. We could do the same thing. We could do then www.foo.com and also make it an A record for the same IP address. Or we could, per 2 weeks ago, make this a CNAME record and have it map not to an IP, but to what? So to an actual name, which could be any name, frankly, on the internet, or it depends on your the software you're using or the registrar you're using. Very often, the @ sign refers to the root name. So if you, for instance, buy your domain from GoDaddy, it's this @ sign that by convention denotes the root of your actual domain. So pros and cons. Why would we maybe want to use an A record for both of these names? What's the upside? Less referencing? Right, so we eliminate one hop, so to speak. We eliminate a potential bit of latency because if the DNS servers know immediately that this name, www, maps to this IP, well, that's it. End of question. It's been answered. But if instead www actually maps to foo.com, that's 2 DNS requests. And that means 2 round-trip times, potentially, just to resolve the additional address. So then if this is so clearly a win in terms of performance, even though we're talking milliseconds most likely, why consider doing a CNAME nonetheless?
Well, if you get a complicated enough DNS record, you're going to make a mistake when you change your IP address, so you get a good chance to. If you've got one IP address to change, you've got a much better chance.
Absolutely. It's just convenience. If you can factor out these configuration details using a constant in, say, programming language terms, it's much easier to then maintain all of your DNS settings if you just have to change one setting one place, and it has the effect of changing things everywhere. Now, there is a gotcha there, which is that you might change it now, but when's the rest of the world going to realize you made that change? Ideally now. Real world, not so much. But why not so much? Yeah, so this is one of the biggest pains in the neck when it comes to actually maintaining your own web servers and your own IP addresses and your own websites and maybe moving them around, changing web hosts, is that there is built into DNS this notion of a TTL, time to live, and that is some number of seconds for which this mapping between name and IP or name and CNAME should be considered valid. So it's usually, say, 30 minutes, 60 minutes, a day. It's it's system administrator configurable, but it is a parameter that they can set. Unfortunately, there's a lot of DNS servers out there that, partly for your convenience, don't necessarily honor that TTL. For instance, a big ISP, to save money, to save traffic, might not want to let you check a DNS record every hour because, my God, like 99, I'm making this up, but 99.99% of websites don't change their IPs within an hour. So why incur all this unnecessary traffic? Why pay for the bits that need to flow onto someone else's network potentially? Just doesn't seem to make sense for these corner cases when people change their IP. Unfortunately, when you're on the receiving end of that corner case, it's really quite frustrating. So what does that mean for you? Well, this quick story I told earlier where one server can have multiple IP addresses, that can sometimes save you, where even though you might want to move a website from one server to another, if you can bring that old IP with you, leave it attached to that server for at least a day, 2, 3 days, just until the propagation on the internet is presumably complete, then you can take back that IP and use it for something else. That's one approach. If you're changing web hosts altogether, though, from like Network Solutions to Computer Science 75 or to DreamHost or whatever, I mean, what can you do if you have to change your IP and literally the IPs are far enough apart, say geographically, that you can't remap, you can't take your IP with you, you have to change your IP. How do you keep your website up?
You set up a redirect on the original server?
So you could do that, right? If the goal is to make sure that no one reaches a dead end, I mean, the short answer is this is really not fun or not easy. But let's see how we could reason through this sort of engineering style. Well, you could bring up a copy of your website at your new location. You could give it, for instance, a name of beta.foo.com so that it has a new name and therefore its own IP address. And then you could, using some tricks we'll see tonight, map www.foo.com and foo.com itself to beta.foo.com. Use a 302 redirect, which is the code for temporary. 301 is permanent, and I think we looked at this briefly last time when playing around. And then 3 days later, then everyone change the DNS records until everyone's going to end up at the new site. Then you can undo this temporary fix. But yeah.
That confuses me. Why not just bring the new one up, and people who get the new IP address will go to the new one. The old one, people will go to the old one for a while, and then gradually you can bring down the old one.
So perfect question. So what is the gotcha with this, of having them both up simultaneously, even at the same name? Yeah.
I had a problem like this when I had a big forum where 1,000 people every day go and update this forum, and I needed to move this forum to another web server. And if I just move DNS, then some people can create a subject on old forum and new forum.
Exactly. It boils down to, if you're taking user input, if you're writing to a database, as will soon be, this is not to say it's not insurmountable, but it definitely becomes more challenging then, because if you have now a database over here, this new one might very well be a copy of the original, but now if you're getting changes written to either, you have to figure out, do you want to synchronize them somehow? Do you want to tolerate some inconsistency? So in short, this is to say, certainly from the course's perspective, that to the extent you could advance plan anytime you're bringing up a website for the first time and do some future proofing, it's certainly a good thing. And by that I mean, don't launch your website on an IP address you know you're going to have to give up in a few days' time, because it just creates problems, but at least through understanding them, you can make some calculated decisions as to the ups and the downsides. All right, so what else is in here that's of interest? Well, the next line's kind of fluffy. Server admin, this is just the default address, webmaster@whatever.com, that you tend to see only when there's an error and you get like a file not found, and you see it in the little footer of the website, but this varies based on the server. The next one, though, is quite important. So I've been saying verbally that thanks to that host:\header in the HTTP request, the server can figure out what directory to go get the .html file from, or .php file, whatever, and this is how that magic happens. You specify in the virtual host container that the root of this website, the document root, as they call it, is specifically that path there. So / on a Linux system, for those unfamiliar, simply denotes the root of the hard drive, like / on a PC. Home is, by convention, where everyone's home directories are on a shared system. Mailin would be my username. And what you'll find after submitting Project Zero is that what we will advise that you do is, once you have a username and password on a server, and I'll connect to this thing and play around certainly in lectures, and you'll see it as well in sections, we will have you create a projects directory, inside of which will be a 0, 1, 2, 3, and final directory. And then you can isolate all of the code that you write for each of the projects to one of those folders. And thanks to a directive like this one and a few other configurations that we'll make sure that www.foo.com/0 maps to that folder specifically, and /1 maps to another folder specifically, all within your control in your so-called home directory or some subdirectory thereof. But thanks to some very basic one-line configuration details, will we be able to map the same structure for everyone in the class just using these configurations. So pretty common stuff, and we'll play with some other configurations over time. Before we dive into this juicier one, any questions, conceptual or technical? Yeah. So this is a file called http.conf, and if you're ever administering your own web server, and you can do this on Mac, Windows, or Linux box these days, you generally have this file somewhere on the hard drive, and you open it up, you're going to see literally this kind of stuff, as well as some other directives as well. And as an aside, if you do start to play, you almost always have to reload or restart the web server for any changes to this thing to take effect, just FYI. And as an aside, even though we will equip you with whatever you need for the course's projects, do know, as I mentioned last week, that among the other resources on the website at E-75.net, if you go to software, turn off our little sniffer there. If you go to software 2, you'll see among the tools we have listed here are something called XAMPP or XAMPP. This is sort of a nice user-friendly way of downloading pretty much everything we're going to use in the course. A MySQL implementation, the installer for MySQL database, Apache, the web server, the PHP interpreter, which we'll start playing with tonight, and a couple of other things as well. Or if you're more comfortable, you can go to the individual websites for MySQL, for PHP, for Apache, and so forth, and install it locally yourself. So lots of options, but if that doesn't strike you as appealing, we will provide you also on the server with everything you need per the specs. So now there's a security implication for running our own websites, especially when we are writing dynamic websites that are driven not by static HTML files, but by dynamic PHP files, or any language really, that need to actually get executed. Because anytime you empower the owner of an account to allow others to execute code, you have to be careful that you've done this correctly so that they can't write scripts that, for instance, email off your password file on the system for someone else to look at, so that they don't delete files that don't belong to them. So in short, they don't touch anything they're not supposed to be able to touch. So imagine a world now, much like the one you're about to use for the course, where you have several hundred users with counts all on the same system. Well, back in the day, it was not uncommon for the web server, Apache, or even in whatever the product might be, to run when it's double-clicked or spawned at startup as, say, root, right? Really back in the day. Now, there's a downside of running any software as root. Root is the so-called administrator account, and what's a downside of running your web server as, say, the root account? Security, but be more specific. What does it really mean? Like, who cares? So you pretty much have access to everything, right? So if there's any bug in the web server itself, if there's any malicious code in the code being executed by the web server, you're letting it do absolutely anything you want on the server. So very quickly did folks realize, all right, we should at least sandbox things like the web server, the mail server, and so forth, so that they run they run as dedicated usernames. Sometimes Apache, sometimes web, sometimes nobody, quote unquote. So just anybody other than root. All right, so now let's assume a world where that's the case. We have now dozens or hundreds of users all on the same system with accounts and thus home directories. All of you are going to be writing executable code in PHP, for instance. This means that when a user visits foo.com/hello.php, that code gets executed as who, according to this logic? Not root, but instead as nobody, or as dub, or as Apache, whatever the username is that's been configured on the server to execute everybody's code. So this is good, in that now, even if I include the equivalent of the delete command in my PHP code, the only persons whose files I can delete are ones owned by, slight trick question. Yeah, okay, so nobody, but if nobody's not even a real person, well, who cares? But there is a gotcha here now. So it's better than root, right? If I were running as root, I could delete anything on the system. I could copy anything on the system. I could do anything I want. If my server is running as root and I am writing code that root executes for me. So if you sandbox things with another username like nobody or web or whatever, we at least address that glaring weakness. But what now happens if, let's say, I am a paying customer? I'm not just a colleague or a classmate. I'm a paying customer. I'm writing some really fancy code, really trying to build my business, and I really don't want people stealing my PHP code and setting up an identical website to mine. The implication of the web server running as nobody or as www means that that username has to be able to read your files. Right? So if unfamiliar, in the world of Linux and even pretty much any modern operating system these days, usernames own files. So if my files are owned by Malin, but I want a user like nobody or the web server to run or execute my files, I have to make sure my files at least give read permissions to nobody or to the web server. The problem, though, with that is that now I can write code that gets executed as nobody. Nobody or whoever has the ability to read any files that are readable by him, which means now, if I'm a malicious customer on this server, I could actually not access my competitors' websites and PHP files directly at the command line, but I could write a PHP file, a website, that when executed doesn't just spit out HTML. It actually goes through all of the other directories on the server, which it has access to because it's running as nobody, and then copy all of my competitors' code, email it to me, and then just print out like hello world. Right, as though I am actually just spitting out a web page. So in other words, if this is a little unclear, if you have to make your code world readable, and the numbers that you usually see in this context, especially from the El Cheapo web hosting companies online, they'll say all of your files have to be 644, which means read and write by you, readable by anyone, readable by anyone, or 755. This is really fly-by-night kind of operation, certainly these days, because this means they are compelling you to make all of your code world-readable to anyone, not in the world per se, but anyone with access to that server, and that might be dozens or hundreds of other clients. So this is totally fine if the files you are giving these permissions to, for those unfamiliar with the octal notation, just means world-readable. This is totally fine for what kinds of files? What, sorry?
For cache or some information what is not important.
Okay, so not important I'll take, certainly. And let me be more specific. So .html files. I'm going to say .gifs, .pings, .css, .js files. And why does it really not matter if those kinds of files are world readable on the server and thus accessible to any other customers? Right, by nature of the web, right? The JS file, HTML file, CSS file, that stuff's supposed to be world readable, otherwise it wouldn't be on the web. Now, password protection aside and all that, but in general, those kinds of static files are generally meant to be world readable. But when you're writing code, as we'll start doing tonight in PHP or any other language, and you're therefore injecting some kind of intellectual property, presumably, you probably don't want to just open up your files to the world, because your files are now meant to get executed, as we'll see, not just spit out verbatim. So thankfully, there are solutions to this. One of them that's quite popular and relatively easy to set up is something called SU-PHP, for Substitute User PHP. This is a module that do I have a little picture? No, I don't. Took it out. This is a web server module that you can generally install relatively easy onto a web server that solves, nicely enough, that problem. So SU generally stands for substitute user, and what this means here is that because I've included this directive, the implication is that any code living in Malin's account, when it gets executed by nobody or by the web server username, is actually going to get run not by that server, but instead by this guy called Malin. So now the only one who I can screw over by writing malicious code is myself, because my code's going to get executed as me, which means, sure, I could delete anything I want on the system that I already have access to, which means I could delete my own code or my own home directory's contents or whatnot. So now I've sandboxed things not only at the system level, away from root to some other username, but specifically even more tightly to my own username. So I mention this because as you shop around for web hosting companies, or even as you run your own systems and really want to isolate things as best as possible as a matter of best practice, this is not all that common on shared hosting companies. This approach, make your files world readable, then things will work, is terribly, terribly common. Now, why is that? Well, one, there's a slight performance penalty that you pay. So for very highly trafficked website, constantly dropping into the different user mode to execute code as specific user, you do pay a performance penalty. But the pushback there is that if you have such a popular site, you're probably not spending $10 a month to host this with 100 other websites, right? You're probably running at that point your own server or virtual private server, in which case you can run it under any one username that you want. There's less of an issue. So this is really germane for really shared web hosting companies. Any questions about this? There's other variants of SU-PHP, but this one is PHP specific. All right, so what else is in here? Well, we'll just wave our hands at some of this. You can also specify within this virtual host directory the kinds of options that you want to enable for a particular website, and we'll see these over time. There's all sorts of options that Apache supports, and by options I mean a feature called mod read write, where you can change URLs, you can redirect user using fairly arcane but powerful syntax, which is quite useful when you want to move things around or redirect users to new forms of URLs. You can, and then specifically we're saying for which directory do we want to turn on this particular SU-PHP engine. All right, so mod rewrite, let's just pluck off one such feature and give a sense of what you can actually do and how websites actually do this stuff. So when you go to cnn.com, where do you end up? http://cnn.com, enter. You get redirected to www.cnn.com. If you don't, well, just you do. Okay, and we did see this last week with Google, right? I'm pretty sure we pulled up google.com, and I kept getting redirected to www.google.com, and recall what the response code was. So let me pull up Firefox here. I'm going to pull up my little sniffing utility again. I'm going to just move one window to the side, and I'm going to go very deliberately, http://google.com/. That is a properly formatted URL. Enter. Whole bunch of stuff happens. Let's look at the first response. And it looks like Google has moved permanently. So I may have requested the host google.com at top there, but really it's telling me, you actually should go to this location. So the magic of redirects really reduces to this one line of response in a so-called HTTP header. Location : is a wonderfully powerful and omnipresent header that says, don't go here. Go here instead. The implication is that you can bounce users from one URL to another, but there's a downside. And what's the downside of this very useful capability? Yeah. Oh, how about in back?
Last week, did you say that this was cached on the user's machine, and so if they receive the move permanently at one time, and then you want to change it at a different time if it's cached on the user's machine?
So that's quite possibly the case. Because this is a moved permanently redirect, the browser should really remember the fact that I've been redirected here, because if it's moved permanently, even if the user asks for google.com again, I know where to send them. Let me just request www.google.com directly. So that's one. Okay, and so that's true. And why is that potentially bad?
Because if you want to change the site that it's redirecting to, then you'll have to somehow fool everybody's machines into reloading.
Okay, good. So you kind of, you make sure you're not going to do something you regret. And maybe this happens very infrequently with something like Google, so it's an acceptable risk to permanently redirect people. And you should take permanently, frankly, with a grain of salt. Pretty much you close that browser window, restart your computer. It's not permanent anymore. We're going to go through the same process again. So it's not permanent in a permanent sense. It's fairly ephemeral, but it's still a real issue within some narrow window of time. How about on a mobile device? You pull up google.com, or many websites these days, and you don't often see the content directly. You're instead redirected to m.something.com or some other URL. Why is this annoying? At least to me.
Because you may want the classic version.
Okay, so that's fair. You might want the real google.com. I paid all this money for this fancy phone with a full-fledged browser. Why are you showing me the chintzy little mobile site now? So one compelling reason. What's another that relates more to performance now? So mobile devices are not very good at minimizing latency, which is to say every time you send a redirect, and you can still feel this in the browser, desktop browser, every time you send a redirect, it's essentially what's happened is the user has requested a page, you have gotten their request, you know what they're asking for, and you just reject them. And you say, no, go here instead. This can happen multiple times, especially if the sysadmins haven't really thought through or have years of cruft or months or whatever of cruft whereby you're redirecting from this to this to this. Every one of those requires maybe 200 milliseconds, 500 milliseconds of traffic back and forth. And so it isn't necessarily the best thing, even if you want to change your URL, to put this burden onto the user. And so do bear this in mind. Anytime you're redirecting users on fast internet connections on the desktop, you might not really notice. They might not really notice, but increasingly on mobile devices, it's frustrating, I think. You pull up a lot of news sites and they redirect you once or twice, and that does take an actual second or 2 seconds, and it's simply because they're sending a little header like this. But it is a useful trick, but how can we actually induce this on an automatic basis? So many websites do standardize on some form of their URL. Possibly for search engine optimization, so that they always appear in some standard branded way, so that when you have a link to your site, it's always of the same form. You don't have some redundancy essentially out there. Or just for marketing reasons. We are www.something.com, or we are not www.something.com. So this is an excerpt from, say, http.conf. This file here, but it can also go in a file called .htaccess, which you'll be able to use on the server if you so choose to use certain features like this. And this rewrite engine directive being turned on says, allow me the power now to rewrite URLs using regular expressions, if familiar, and allow me to redirect people on a configuration file basis. So how is this actually working? Well, this, frankly, takes a little bit of getting used to, and Google here is your friend with examples, especially if you want to do fancier things. But it's pretty easy to understand once you know what to look for. So we have first line is just turning the feature on. Second line is a condition. Third thing is like a then clause. Do this if the condition applies. So rewrite the condition. This essentially is saying if the value of HTTP host, which is the fully qualified, which is the value of the host : field that came in, is not equal to www.mailinrouge.com, then bounce the user to www.mailinrouge.com. But let's tease apart a few pieces of syntax here. So the bang sign means not, as you're probably familiar. The caret sign, though, means starts at. So this is a regular expression, which means a pattern that you're trying to match against, and the caret symbol means start matching at the very beginning of the host line. Now, this isn't probably terribly necessary in this case, but if for some crazy reason the website had a subdomain of www.mailinrouge.com, that would not actually match against this expression. Here, it's probably irrelevant, but I'm just being pedantic by including it. www.mailinrouge.com, and the $ means match to the very end. This, too, not really relevant because there are no 4-letter TLDs that end with COM, so it's not really germane. But again, in the interest of being thorough, and I actually cut a corner for readability's sake. Technically, each of these dots in this context denote what? So they denote, any character, any one character. Now, I actually want a literal dot, so if I were really being anal, I'd do / here. But the odds of my getting a request for www.malanro, it's not going to happen, so this is pretty good, and it's more readable to me, but we could add the backslashes to say a literal period. Now, down here, what are we saying? Well, here, in the parentheses, we are saying match, in parentheses, everything after the host name, everything after the / essentially. And the parentheses mean put this in a variable so I can use it later. Now, what does that mean? Well, I want to redirect the user to this URL /$1. There's that variable. It's automatically given the name $1, but the fact that I am now appending it to the end of the URL that I'm sending the user to, having captured it with this syntax here, means that unlike some websites, when they redirect you, they bounce you back to their home page, and then you have to figure out how to get back to the page you actually cared about. Well, with this, can you retain some state and actually bounce the user back to a different subdomain, like www.mailinrouge.com, but keep them at the same path, the same HTML file, the same PHP file, whatever. And this is an unfortunate, it is this easy in most web servers to do this. There's some website where I tend to read Google News on my iPhone, and I'll follow links that then are supposed to lead to the real version of the website, the desktop version of this news site, whatever it is, but they sniff my browser agent. They realize, oh, you're on an iPhone, let's send you to our mobile site, and they send me to the homepage of their mobile site. I never once can read the articles on this site because they bounce me away from it. And literally, it boils down to, depending on their server, probably, honestly, one line of configuration like this to actually fix that problem. So, but for now, the takeaway is just what the capabilities of this are. But there's a couple bracketed expressions. NC, anyone want to take a stab at what that denotes on top right there? What's that?
The number of error?
No, not the number. It's hard to guess. No case. This is the way they decided to represent case insensitive, so that if for whatever reason the host line, and it doesn't have to be a host line, if the value you're actually matching against happens to be all caps, doesn't matter. So this means case insensitive. And this one we are familiar, if you infer. R means return response code. 301 means this is a permanent redirect, which again is not so much permanent as it is a strong request to the browser to stop asking me the same question again and again. Just you assume this answer. And L means last, which means if there's additional conditions or rewrite rules, you don't actually get to them at that point. This particular block of code stops executing. All right. Any questions? All right, so why don't we do this? Why don't we take a 5-minute break? I'm going to open some windows because it's kind of warm in here, and then we'll resume with some more PHP. All right. So we are back. So as promised, some comments on sections. So sections, for those unfamiliar, is an opportunity to meet outside of lectures with one of the teaching fellows in a generally more intimate environment. So you can do some additional coding examples, talk specifically about the week's project, and really just get questions answered that you might not have felt comfortable asking during class or just hadn't thought about. So we've posted, as you may have seen from Dan's note, a schedule of sections on the course's website. Alex, the gentleman in here in back left, will be leading tonight's section, which will be right after class, across the hallway, essentially. And then moving forward, we'll have ones on Thursday and Monday. You're welcome to attend either or both. In general, it's entirely up to you. And one of those will be filmed each week and placed online if you simply can't make either, particularly for those of you playing along at home. Any questions about... Oh, and to address a specific question that came up. So we don't assign to specific sections. You're welcome to go to either or to both. It really depends on your own schedule. Was that the different question?
When there's a Monday holiday, are there no sections on Monday?
Correct. So if there's a Monday holiday, we wouldn't have lecture either, so the syllabus takes that into account already. Other questions? No? Yep.
You said that across the hall.
Yep, the room here is 102 for Alex's section, Harvard Hall 102, which is across the hall. And then Sid's section, which is taking place this Thursday, is in Harvard Square at 1 Story Street, number 302. It's the Extension School's videography building. All right. So it turns out I did have a picture of XAMPP or XAMPP all along. But again, this is really just an optional tool. And it's actually useful, frankly, if you like to do client-side development or you want to travel on a laptop and don't want to have to be connected to the internet and thus a server all the time. Pretty much comes with most everything you want. WAMP is another one, the M being the only difference there. OK, so we concluded last time looking at forms as being really the building blocks of most everything we're going to do this semester. And in fact, it's kind of a funny thing that as increasingly as the web is getting, still the UIs we interact with pretty much reduced to some fairly basic things that have been with us for some time. Text fields into which you type search queries, password fields, which are just a variant of that. There are checkboxes, radio buttons, select menus, and bigger text boxes, and then also hidden fields. And that's about it. Now, thanks to libraries and whatnot, folks have started implementing variations on these things with autocomplete and the like. But for the most part, they still boil down to the same basics that we've been with for many, many years right now. And what's nice is that they map very nicely onto the discussions we've had thus far on HTTP. Every one of these form inputs simply maps to what we'll call an HTTP parameter that is sent either in the URL of a request or in the body of a request if you're using something called POST. So let's actually tease this apart. You're probably familiar with the site that used to look like this. Now it's becoming increasingly what do they call it? What's that new feature? The auto... Instant search? Yeah, Google got very fancy recently. They've had that fade on the homepage for a while now. And now they have this instant search where it uses this technology called AJAX, which we ourselves will start using in a few weeks' time to grab results dynamically and just minimize latency and minimize the amount of time the user spends looking at a spinning hourglass or the like to go get more data. It's a bit more of an interactive experience. But as an aside, out of curiosity, how many folks are familiar with instant search? Okay, so about half. So then, terribly quick demo, just for those unfamiliar to set the stage. If I go to www.google.com And let's go to classic Google because I'm on the SSL version. So now I have, well, actually, let's see if we can induce this. Oh, they got rid of the fadeaway right now. All right, so let's start searching. I am going to search for computer. Notice I haven't even hit enter yet, and now the whole Google is changing. Computer science course at. So this is the new feature. It's not clear to me this is actually a win overall. But Harvard, let's say building. Let's see if we, okay, building, dynamic. Ooh, that's pretty good. Hey, that's us. Not bad. You can search for us. Building 19. So you need at least building deck stairs. We've been beaten out by building deck stairs. Hey, that is not bad. Building DY. So there we are, this particular course in a couple of places. Anyhow, that was completely a tangent on my part. Just got curious. But the point, though, is that there's actually a couple interesting takeaways, particularly germane to our future conversation on scalability. This is a nightmare, frankly, for the guys who have to operate the engineering side of things at Google, whereby every time I hit a character on the keyboard now, or a couple of characters, what's happening? So it's refreshing, or specifically, it's inducing an HTTP request from browser to server that even though I'm not seeing a whole page reload, that's still load on their server. So whereas before a 10-character, 20-character Google search would result in one HTTP hit to Google servers, graphics and such aside, now it's like one per keystroke. And if you're a really slow typer, you can really hammer the heck out of their servers because presumably if you type fast enough, they'll wait until you type a few characters and then send it off. Yeah? So hopefully, I haven't taken a close look underneath the hood. They certainly couldn't cache all possible variants of your typing, but they could certainly and probably are doing some prefetching, whereby if you do start typing D, Y, N for dynamic, maybe they actually do prefetch not just the dynamic results, but the most popular words that start with those three letters so that they can then think ahead and get ahead of the curve with some of the autocompletes. But absolutely are they inducing many more requests than they once were. In fact, we can use our little friend here, Firebug. Let me pull up this time not Safari, but Firefox. I'm going to go ahead and go to the bottom here. Actually, maybe this is what I was using before, but I just wasn't looking. So notice at the bottom of Firebug, generally by default, you're in the console tab, and we'll play with this over time. I'm going to go to the net tab now and start typing that again. Building. So every time, 15 requests. 16, dynamic, web. So it almost is one request per character, at least at the speed I'm typing. And let me go ahead and zoom in on one of these. So I can click in on this response. Let me fill this page here. So notice I'm hitting their server. Here's my response. Here's their response at the top. Here's my request at the top. Let me see what the response is. And now this is what's apparently coming back from Google. Let me zoom in. So when I search for building dynamic websites, this is what I'm getting back. What in the world is this? So frankly, this is probably some pretty clever computer science going on here, so that they appear to be returning, looks like an interesting encoding of strings that is perhaps optimized to return, I presume, the fewest characters possible of a string while still answering the question. So it looks like there's a lot of Unicode characters here, maybe, I'm guessing, or these simply happen to represent indices into this chunk of code that they're sending back. In short, someone who took a data structures course probably implemented this particular search feature. It's not as naive as just returning a big array of strings. It's not returning JSON code per se, it seems. We'll start simpler. We won't worry too much about optimizing for billions of hits per day just yet. But the takeaway for now is that all this is boiling down to some basic HTTP. So let's take a look at the actual request that's going across the wire. So let me go back to, let me clear my cache just so that there is no artifacts from these past searches. And as an aside, whether you're using Firefox or anything else when developing, especially for this course or in general, clearing your cache or using some tool that does this kind of thing for you is necessary often so that you're sure you're not chasing some bug that actually doesn't exist anymore. It's just cached somewhere locally. So let me clear this cache. Let me go back to google.com. And now I'm going to go up to, there's a way to simplify this, right? Search settings. I want to go back to the old Google. There we go. Do not use Google Instant. I wanted to go 1990s style here. So let me pull this back down. All right, so now I don't want all these requests. I just want one particularly interesting one. So let's go ahead and just type in Harvard. Oh, stupid thing's still doing it. All right, now that's just their autocomplete. Now I'm going to click Google Search. I've cleared the rest. So I'm going to click Google Search. And what I really care about is this first one. So I'm going to zoom in on what was just sent across the wire. So here I have in Firebug the response that came back from the server and the request. But what's nice is that Firebug, among other things, will nicely parse this out. So I'm just going to click params. So all those things that you generally see concatenated together in a long URL is nicely teased apart here. Generally, URLs, as I think we saw 2 weeks ago, are something equal foo equals bar, ampersand, and then another key equals value, another key equals value. Well, this is just a nicely rendered version of that. Now, I only typed Harvard. So apparently some of these other things like EN, probably for English, was pre-configured in the web page. HP, whatever that happens to mean. Google Search, that's the value of the button. So even the value of buttons are sent, if unnecessarily. And then there's some weird thing there, GS, RFAI, whatever that kind of key is. But the point for now is that I filled out a form that sent in at least one useful parameter called Q. Can I re-implement this thing myself? Well, let's take a look at whether or not we can. I'm going to go back to google.com, and I'm going to go to view its source. Oh, there's that page fade. It's back on the old school version. Unfortunately, Google source code looks like a mess these days. Right? It's minified for performance reasons, presumably. Use as few bytes as possible. But how do I even begin to find the HTML? I see a head tag up there. That's familiar. Maybe there's some other stuff in there. Well, let's do this sort of the developer way. Let's again pull up Firebug, click HTML, which is just going to pretty print all of this for me. So I'm going to expand. Notice on the left here, I've got the HTML, the head, the body, and all of this has been cleaned up for me. And let me dive in here. I'm not quite sure where it is. Actually, I don't know where I'm going, so I'm going to cheat. I'm going to right-click on the form itself, choose Inspect Element so that it zooms right there. And I don't have to go fishing around the so-called DOM, Document Object Model, for it. What I really care about is the form. So here it is. We promised that pretty much everything we do in this class reduces to some basic form inputs. There is the form. So in a form in HTML, if unfamiliar, you have the form tag name itself. You can optionally have a name for the form, as they have here. But you will definitely need the action attribute. Action, as the name kind of implies, means send this form submission here. That does not have to be a .php file per se. Doesn't have to be a .cgi file per se. Probably shouldn't be a .html file. Otherwise, there's no one intelligent listening to actually process the request. You need a dynamic page or language listening there. So /search probably maps to something like search.py for Python or search.php or whatever implementation they use. I think they tend still to use Python for user-facing stuff, but just making that up. So now they have a table to lay things out here. All right, there's a lot of fluff here. I really only care about the form, so let's see if we can't find the juicy stuff. Let me scroll down. Let's see. I'm going to highlight over these spans. There's a button, but I want oh, there it is, input. So there's a whole lot of CSS getting in my way here, but germane to the discussion is the input tag here that I'm hovering over. A lot of fluffy CSS. And then we get to size. Okay, a little more interesting. Value equals, title equals, name equals Q. That's really the important thing. So ultimately, I have a form whose action is /search and who's got a form field called Q that is apparently of type text, because later on, where's that type equals text? Hopefully over to the right. Where is it? Type equals text. Oh, they're cutting corners. The default type is text. So they haven't even specified type equals text. They're just leveraging defaults that browsers assume. Then there's some other stuff. There's a button. There's a couple buttons. Let's just look at one of them. I think it's over here in this span, deep in here. Yep. So another input. This time the type equals submit, and the value is equals Google search. All right. So the takeaway here is that there's not all that much going on, certainly on the front end of Google. And if you ignore all the fancy fading and all of that these days, it's the same primitives as from 1990s. So let's go ahead and do this. I'm going to connect to one of the course's servers, cs75.net itself, even though you'll be using the cloud.cs75.net more generally. So let me go ahead and log in with our own accounts here. For those unfamiliar, I am using macOS's terminal program. This gives me a command line environment on my own Mac, and I'm using this to use a protocol or program called SSH, which allows me to connect to a remote server, albeit in a command line environment. Folks with Windows will probably want to use a program called PuTTY, which is a free utility. It's a little prettier in that it's a GUI, but at the end of the day, it does the same thing. You don't have to use this interface entirely, but it is a common way of interfacing with a Unix-type system. So I've just logged in with my password. I'm going to go into our lectures directory for today, and I'll make all of this stuff available online. And let me go ahead and let me start here, actually. I'm going to use a file called google.html. Let me increase my font size, and I'm very quickly going to whip up a web page. It's not going to be perfectly valid with XHTML because I just want to get some basic structure up. How about we'll call it fake Google. All right, title. And close my head tag, open my body tag, close my body tag, close the HTML tag, and then I'm going to go to cs75.net/lecture/lecture1/google.html, and there's a problem. Why am I getting this? Yeah, so it's this issue here. So there's different ways of doing this on different systems. I'm going to go ahead and I'll show you briefly both, but I could do chmod for change mode 644 of this Google file, or I can be more sort of user-friendly, chmod change mode. Everybody should get added read access, and now I can say that. So now if I go back here and reload, still problem. Let me cheat. I didn't give the directory executable permissions, but never mind that for now. We'll document that as needed. OK, so here is my implementation of Google. It's coming along. Let me go back into the file itself and just do a little sanity check. To do finish Google. All right, so go here. OK, so coming along, just confirming that I am actually doing this in real time. This is not a prefab demo. So let's go ahead now and add this form. So form. Action equals, I don't really have the back end implemented yet, so we'll leave that alone. Close form. And here I'm going to do, let's say, input. I'll be deliberate. Type equals text. And then I'm going to say name equals Q. I'm going to just put a line break just to keep it simple. And then input type equals button. And then I need a value equals fake search. And anything else? I could put a name here, but I'm going to leave it out. I'm going to really make this thing bare bones. Now let's see what I've got going on. OK, so coming along, it's a little not quite like Google, so I'm going to tweak things a little bit. Let me go ahead and, just to be anal, div align equals center. We'll put that over here. I'll move these things in here. All right, div. OK, so now we're coming along. And now I'll just cheat and zoom in like this so we can see it better. All right, so now I have the beginnings of Google. Unfortunately, if I type in something like building and hit enter, where do I go? Well, back to myself, which is pretty useless because this is a .html file. So you know what? I'm going to outsource this. So I'm going to go back up to the action line. I can't just do search, because if I do this, let me go ahead and reload and try this again. Building. Well, that's just going to go to the website, the slash part of the website, which certainly doesn't know how to process search queries. So let's go back and try this again. Let's instead this time, you know what? Google's done a pretty good job. Maybe I can just kind of ride their coattails. So let's prefix this with the actual full URL, google.com/search. Now let's reload my page to make sure I get the latest version. And I do building, dynamic website, enter. Ooh, so very nice. Now I'm using Google as a backend for my very own search engine. So what are the takeaways? Well, it really is this simple to actually get input from the user so long as there's something on the server listening for that request and processing it. So Google is surely a dynamic website. How do we now start building these pieces ourselves? Well, let's actually deploy a tiny little bit of PHP. So PHP is what's called an interpreted language. That means that you don't write code, then compile it with GCC or Visual Studio and output zeros and ones. You just write your source code, and that's it. Because your files, by convention, end with the file extension .php, that is a hint to the web server, for instance, Apache or IIS or any number of other servers, to not just grab this file when it's requested in a URL and spit it out like it would an HTML page, but instead to interpret it, specifically to grab that .php file from the disk, to hand it to a program generally called php.exe or equivalent, let it take that file as input, it spits out output, and what does the server send to the browser? The output of that interpretation. So an upside of this approach, an interpreted approach versus compiled, is generally what? What's that? It's what? Speed in what sense?
You don't lose time compiling the code and generating other content.
Yeah, absolutely. So the speed of it, right? I don't have to waste time compiling, waiting for things to compile. I can make one tweak, bam, reload my browser, and I'm on my way. It's actually a pleasant experience, relatively speaking. There's not an additional step. Now, speed is also the opposite answer. What's a downside of an interpreted approach? I say speed. Why is that, though? So it runs slower, so whereas it might very well benefit the human, and that alone is certainly compelling depending on whose time's more valuable, the CPUs or the humans, well, there's this cost that's involved in actually translating what's pretty much still English-like syntax to those zeros and ones, which ultimately need to get fed into the CPU. So whereas with compilation, when you run GCC, when you run Visual Studio, you're actually getting the zeros and ones that can be handed directly to the Intel CPU or whatnot. With an interpreted language, there needs to be a little pre-processing done. Now, smart implementations of interpreters, PHP has these, can cache the resulting runtime compilation of your source code into opcodes, as it's generally called, so it doesn't have to do this again and again completely foolishly. But by default, your code gets essentially just-in-time compiled every time it's executed and sent to the browser. So this has an implication, not so much for like projects, certainly, not so much for relatively small websites getting a few dozen, few hundred hits per second even, but when you start talking about thousands of hits per second. Because if you do need to incur a CPU cost, well, you only have a finite number of CPU cycles per unit of time, so at some point you're going to hit a breaking point where you can only handle so many users, at which point you need another server, another language, or some modifications to your setup. But again, more on that in our scalability discussion. So, PHP, why just put a URL up here? Honestly, one of the most compelling things about PHP, at least for folks learning it, is that it's so friendly when it comes to learning. The manual is outstanding. Not only do you see functions documented very thoroughly, they all come with sample usage and number of examples. They also have, unlike most websites, comment threads and discussions by other developers that must be moderated because they're actually intelligent, and they're generally quite useful because you yourself might have a frequently asked question about a function, and odds are one of these nice people has posted their own code, small function for instance, that solves the problem that you might have. So it's actually a really nice community, even if you're just a passive reader of the content that's actually there. So certainly for folks coming with prior programming backgrounds, of all of the languages that are in vogue these days, PHP is a wonderful tool when it comes to teaching yourself pretty rapidly. So as such, the learning curve tends to be relatively low, which is why we like it. Popular alternatives these days, certainly Ruby, Python, definitely good, but at least personally, the documentation here, they take the cake. So, with that said, what can we actually do with some PHP code here? Well, let's go ahead and whip up google.php. So I'm going to go ahead and start writing what's just a text file, program in PHP and just a text file like most any other language. And I just want to do something simple at first. I'm not going to do anything interesting except give us a basic structure. So I'm going to go ahead and open bracket, question mark, PHP, which says enter PHP mode, and then I'm going to do almost the opposite at the bottom of that. So this is a block of code now that when handed to the PHP interpreter is going to get recognized as, oh, there's some PHP code in here. Let me read and execute this code. But if there's anything, outside of those blocks, it will just spit it out verbatim. Which is to say, one common approach to writing PHP code is actually to commingle HTML and PHP by just dropping in and out of PHP mode by using these tags wherever you want to do something dynamic as opposed to static.
What's the container on the server that's actually executing your PHP? Is that in Apache?
Good question. It depends. In the case of Apache, it's generally implemented as a module, which means it's actually running as the Apache user ID. It's either been compiled into the binary or Apache has this modular capability, but it is the web server itself. Whereas some languages have the notion of an application server, at least with PHP, they tend to be one and the same, web server and interpreter. Other approaches include something called fast CGI, whereby the web server has the ability to invoke on the system almost any interpreter for Perl, for PHP, and what happens is it literally hands the input like foo.php to /user/bin/php, gets back the result from what really is just a command line binary. So that approach is possible too. And other web servers take different approaches. It depends. nice. Apache has this nice module approach, which is nice because you run one command on most systems and bam, you have PHP support, which is nice. So it turns out you don't have to always include the PHP. Frankly, it tends to be a little bit annoying, at least in your own personal projects. This is just a configurable option that you can enable or disable, just so you've heard it before. Generally, this is beyond one's own control on a shared web host, but the PHP configuration file, similar in spirit to this guy for Apache, is generally called php.ini. So if you download XAMPP or your own version of PHP, that's the file in which you can configure things like this. So in general, I will almost always just use what are called short tags because I frankly just like the symmetry of it and the simplicity. But as an FYI, if you're ever writing code that's meant for people to use on other servers, if you're a developer who's sort of working with other teams of developers, it's minorly obnoxious to use these shorthand notations that compel the other people to enable features on their web server just to support your choice of syntax. So in general, when I'm writing projects for myself, I absolutely take this shorthand approach. But if I'm ever writing a library or functions that other people need to interface with, I do them the favor of not forcing them to change their own configuration just because I was a little lazy. So just keep that in mind depending on how you tend to work. So let's do something incredibly simple at first. There is a function called print R for print recursive, and you can print the contents of any variable. PHP comes with a bunch of special variables, generally called super global variables. They're all capitalized, and they start with an underscore. So they look a little ugly, but they also start with a $sign, which is the case for any PHP variable. So new piece of syntax here. Turns out one of these super globals is called $_get. And as the name implies, inside of this variable is going to be an associative array, a hash table, that contains all of the key value pairs, all of the parameters that came from a form on the web. So the goal right now is to print to the screen just the contents of what the browser is sending to me, just as a diagnostic. And then we'll actually do something interesting with it. So let me go back. And actually, I'm going to be a little more anal here. Let me do this. I'm going to say first print a pre-tag, because I know a little bit of HTML, and this. So not at all a dynamic application yet. It's just a quick and dirty dump of the contents of this variable. So now let's go ahead and do this. Let me go back to google.html, which itself does not have to be dynamic to be sending data to a dynamic site. I'm going to go ahead and stop using Google. Actually, let me, for the sake of leaving the code available online, let me go ahead and make a couple versions of this. So let me move this original version to google1.html, and I'll post that online later. And I'm going to make a copy called google2.html, which we'll use for this variant. So google2, vi google2. So now I'm going to map this not to Google, but to my local file, google.php. I'm going to rename this 2 so that we have a correspondence, and this is simple to keep track of. Move google.php, move google2.php. OK, so now I'm going to go back to my browser, and I'm going to go to cs75.net/lectures. 1 google2.html still looks the same. So now let's go ahead and type in, let's say, building, click fake search, and what comes back? What does come back? That's not what's supposed to come back. google2.php. What's going on? Reload this. There we go. OK, browser error or user error. OK, so what did I get back? Apparently, just some diagnostic information where Q was apparently submitted to the server. And this is just arbitrary syntax that PHP's print R function takes. But herein lies the contents of that form submission. Let's do a little sanity check now. If I go back to my HTML file and this time actually give a name to this button like Google does, I think they call it name equals btng, button Google maybe. Let me go back to my HTML, reload, and this time type it again, fake search. And my browser is not behaving very well. Building, fake search. Weird, sorry. What is going on here? Save, button G, yeah. All right, when in doubt, clear your cache. All right, building. Google. Yeah, but I think, sorry, let me take a quick look here. No, it's there. Button G. Oh, I know what it is. Fake search. Oh, my God. Oh, wait a minute. Sorry. Thank you. Okay. Well, thank you to me. Okay. So the button, I wasn't copying Google's forms exactly. Recall that the type they chose was submit. That was for a reason, so that the value would actually get submitted. Sorry, wasn't even practicing what I was preaching. So now let me go ahead and type building, hit enter, and now things are working. Sorry about that. All right, so one get out of jail free card each now. So with the contents now, do I see that, okay, 2 values are being submitted. But the more interesting aspect is, how is this getting there? Well, if you zoom in on the URL, which you generally don't look that closely at, especially as they get particularly long, this is how the data is being sent. So when you set a GET request, GET / then whatever the path is, then HTTP 1.1, well, what is it that's actually going across the wire? Well, if it's not just / but it's actually a form submission, all of those parameters are included, as we said, after that part of the URL. Specifically, you have the name of the file you're actually sending the info to, Google2.php in this case, the action attribute, followed by a question mark, which says, here comes my parameters. And after that, you get foo equals bar, and baz equals quux, and whatever the key value pairs happen to be named. So it's a little small up there, but you can see q equals building, and button G equals fake plus search. I didn't type the plus. Why the plus? So it's a space character, so that URLs do not have white space in them. They are what's called URL encoded generally, and the browser does this for you automatically. We ourselves may have to do this programmatically eventually if we want to ensure that URLs we create with PHP are similarly of that structure. But thankfully, you'll see PHP has a URL encode function. There's an alternative approach, though, with a form. And I didn't include a method last time. Get was assumed. But if I instead do method equals post, what again is the difference between get and post? At least so far as we can tell. Yeah, so the first immediate difference is if you submit a form via post, you don't actually see any of the posted parameters in the URL itself. So let me go back here and reload this page. Type in building again, and now this time click submit, and notice the URL changed, but it didn't get any longer. It did submit to the action specified in the file, google2.php, but where was the information sent? Well, let's actually look at our friend Firebug here. Let me reload so the same thing happens, and notice too, in terms of UI decisions and design decisions, if you reload a page to which you've posted information, you generally get a confirmation like this. Now, this is good because it's the browser's way of telling you what? You're definitely about to resubmit a form of some sort. Now, why might you want to know that you're about to resubmit a form? I mean, who cares? I know I'm doing that. I hit reload. Yeah. Yeah, you may be paying for something twice, for instance. Now, thankfully, this is largely a 1990s problem where websites have realized that with a simple if condition, you can avoid selling someone something twice. There's various ways of doing this, but absolutely still happens, certainly on some websites. Or if you're just submitting information, you might submit to trouble tickets or something. If you resubmit the same form, you might not want to, and so this is a bit of a warning. But the implication here is, too, for programmers, that if you want, it's not easy for you, the programmer, to induce a post necessarily without the user becoming aware of it. So when we start talking about AJAX and such, we will be able to use post operations, but we're going to be doing it behind the scenes in JavaScript, not through HTML like this. So let me go ahead and resend that. That's fine by me, because I actually want to see in Firebug what went across the wire. So if we look at our request headers, we indeed see, if we look at our request headers, we indeed see the host line as we expected. But where are the actual parameters? Well, let me zoom out here, and let me go to view source. So notice here it's subtle. It's a little grayed out, but I'm going to click source. This is the actual request that was sent. It's a little more detailed than it shows me otherwise by default. So here is that line. Instead of get, we see post, and notice we don't actually see the parameters after the header there. They are, in fact, and Firebug's not showing me absolutely everything, they're sent after these HTTP headers. So let's take a quick look, actually. Let me close Firebug and look even deeper using the pure live HTTP headers plugin. Let me go ahead now and reload this page. Yes, I do want to resubmit. Let's see what's really sent, and there it is. So now we start off by saying post instead of get. Well, where are the parameters? They're not in the URL. They're not after the slash. Here they are here. So why use post instead of get?
Conceal the arguments that have been passed.
So good, that's a big one, to conceal the arguments. If you're logging into a website or submitting a credit card information, sure, you could submit that form via get, but that's going to now appear in the URL. Now, okay, it's my credit card number, it's my password, I typed it in, who cares? Well, why might that be a bad thing, to just submit via get in the URL for info like that? Yeah.
It would take packet inspection in order to detect what the parameters submitted with post are, whereas it wouldn't take packet inspection in order to actually intercept the GET request?
Not quite. It's a good thought when it comes to inspecting packets, but it's pretty much the same, because at the end of the day, this is still at layer 5 and inside the HTTP request. So it's in a different place, but it's really no fundamentally harder. Yeah?
Someone can find this information in Apache logs.
Okay, so that's a good one, actually. Not only do you leave traces in, let's say, your own history in your browser, also generally when a web server logs requests to the server, it logs the request string, not the post for efficiency reasons, but the whole get string, which means if you did submit your username and password, not only would you be authenticating against that site, you might now appear every day, every time you log into their website in their logs, and this is probably not information you want to disclose. In theory, even though their sysadmins could be looking at your usernames and passwords, I mean, now you're literally handing it to them in a text file and to be archived probably in perpetuity. So in general, if you don't want the data to linger around in the browser's history or in the logs, certainly, you want to resort to post, but also for other reasons. Imagine using one of your favorite websites like Facebook or Twitter or Flickr, anything where you have to upload some non-trivial amount of content. Well, how big would that URL be? Right? So there is a way, an image, even though it's graphical, really is just zeros and ones. And we can represent those zeros and ones using some kind of ASCII or Unicode encoding. And certainly could we represent a photograph even as a long string of characters in a URL. But most browsers actually have a limit on the length of URL they support. Does anyone know what the official limit is? Yeah?
I guess 1024 characters.
It's not bad. So it's kind of a trick question on my part. There is no official limit. And this is actually really, really annoying that this is not stated in the specification, because it means even if Firefox supports, I think, something ridiculous, like 65,000 characters, well, you pretty much have to deal with the lowest common denominator, which, forget at the time, was Safari or Internet Explorer, which was roughly 1024. Now, there might be higher limits these days, but this is one of those areas where you just kind of know when your URLs are getting too long, right? When things start wrapping in emails, then it can be a problem for users forwarding them around. But if if you have to scroll and scroll and scroll to see your URL, probably you as the developer made a poor design decision in using these long URLs, because at some point that might very well break, whether in the browser itself or in an email. So where is the line? 1024 is pretty reasonable. And even then, if you're approaching a few hundred, probably the URL is longer than it really needs to be. So you can use post. What's nice about post is there is no limit, because what you see at the bottom of the post request is first a queue to the browser, who are we talking about here? To the server. How long is the request I'm sending you? How many bytes? And then what the browser does is it just enumerates those bytes, top to bottom, left to right. Even if it's 10 megabytes, 20 megabytes, it can all be sent in this way. And so the server doesn't have to know in advance that it's all going to fit in this long string. It can just keep reading up until it's read that many bytes. Then it knows that it's actually done. And with post 2, can you then hide information a little more effectively, not securely. This has nothing to do with crypto. You can sniff all the same traffic, but at least you're raising the bar and not just handing it to no eavesdroppers in your history or in those log files. All right, so what's the takeaway for us? Well, let me go back to my little fake Google. I've changed my method to post. Let me go back to the browser here. Let me go ahead and resubmit as I just did. And unfortunately, I'm getting back an empty super global array. And why is this all of a sudden empty, even though I still typed in building and had that button G? Yeah, exactly. So there are different superglobals. And the second one, perhaps just as useful, is this thing called post. So in Google 2.php, I previously had get. If I change this now to post, I can now get access to those same variables again. There they are back. If I want more of an all-inclusive container, there's also something called request, which lumps get and post but also cookies together, which is not necessarily a good thing, and I can still get the data there. In general, don't use request. You should know what you're doing. Pick get, pick post. Unless you really know what you're doing, you can resort to request to save some lines of code. But this is very much out of context now, right? If this is PHP, I mean, this is really a waste of time if this is all we can do with this. So let's actually do something that's a little more useful now. So let me go ahead and let me make a copy of one of my files, google2.html. Let's call this google3.html. And then I'm going to copy google3.html into google3.php. In other words, I now have, let me do my chmodding as before. I now have google3.html is going to submit the same info for now to, and we're going to get rid of this name because I really don't care what the button is called, to google3.php. Google3.php at the moment is identical. So that's okay. We're going to see different ways of doing this. I don't want a form anymore. I don't want this form anymore because this is now going to be the program that processes it. But at the moment, I am just a to-do page. So let's see what happens here. I go back to google3.html, which again is our third variant. Looks the same. Let's go ahead and type in building and hit enter. All right. So I'm submitting to a PHP file, and yet curiously, that PHP file is not actually PHP just because I say it's so. It's still just HTML. But there is some interpretation going on, but there's no actual execution of code because what is missing from this .php file inside? There's no mention of, open bracket question mark or question mark close bracket. But we can do this, and herein lies the commingled potential of PHP and HTML. You can start writing some pretty bad code this way, but one of the reasons that PHP has become so popular is partly because it's so easy and because it was designed with HTML integration in mind. It wasn't just shoehorned in as a popular language that now people want to use on the web. So let's go ahead and do this. Open bracket question mark. I'm going to say print. So there's a few functions. We did print recursive, but now I want to be more specific. I want to print the contents of post, but specifically what parameter? I want the Q parameter here. So I'm going to write one line of code like that. I'm going to use my semicolon, even though here it's not strictly necessary. And just to be a little clever, I'm going to say you searched for. And now, this is where PHP starts to get powerful and interesting. When you want to actually do a little something dynamic, you can embed it where you want. And again, as an aside, you can start to make things very messy in this way, so you can factor things out and have what are called templates, and there are a lot of solutions to this. For now, we're going to keep it simple. But the point here is that here's that same superglobal called post, but I'm indexing into this superglobal because it's just an array. It's a hash table. It's a map. Call it whatever you want for now. Specifically, I want that parameter's value. So let's go ahead and take a look now at the result. So that's google3.php. Let me go back to my form and resubmit my fake search. And there it is. So now here's a dynamic page. If I look at the source code for this page, that is indeed what I get back. This is server-side executed code. Unlike JavaScript, which we're going to see the code for in weeks to come on the client, here you're only seeing the result of the server's execution of that file. So now we have it executed dynamically. Well, let's do something that's a little more interesting still. Let me open up a file that I prefabbed in advance called frosh.ims, let's say 1.html. Let me go ahead and open this up, and this will be available online after if you'd like to play. Let's go into source, frosh.ims 1. So this was motivated by a very real-world example. Long story short, when I was in college back in the day, we would register for intramural sports by literally walking across the yard, filling out a piece of paper, and sliding it under a door. Right? Not all that unreasonable, but kind of old school, even at the time. So one of the first projects I ever learned in web programming was a website with which you register by staying in your dorm room and filling out a form, and then the person receiving those pieces of paper now received emails instead. So marginal improvement, kind of some low-hanging fruit, but what was nice about this is that there were literally several different form mechanisms, not just a text field. Now we're doing something a little more interesting and familiar. So here I have two text fields, name and email, a checkbox to say, yes, I want to be captain, a gender radio button that's mutually exclusive, and then a dorm, which is a select menu. So pretty much the most popular UI mechanisms. Well, this form at the moment, if I look at the source code, is going to submit to, and I'll zoom in a sec, it's going to submit to frosh.ims1.php. And this first frosh.ims1 example is actually pretty simplistic because I just wanted to do a little sanity check. So this time I actually commented it, but again, I'm just using some pre-tags, and I'm printing out recursively the contents of get. This is not a real web page. There's no HTML tag, B tag. I am trusting that my browser, just for demonstration purposes, is just going to blindly interpret the pre-tag as HTML and therefore show this in a nice monospaced font. So this is just going to show me now what is inside that super global when I submit a more interesting form. So here we go. Name is David. The mail-in, Harvard EDU. Sure, I'll be captain. Sure. Pick a dorm down here. And now I click register. And now let me sniff this traffic so we can see what it looks like later. And let me go ahead and click register. OK, so it's got a little more interesting, the output. Before we look at what was actually submitted or what was received, let's look at what was submitted. If I go to my net tab here and I expand the request that went across the wire, here are the parameters that were sent. And it's pretty much as you would expect, but there's a couple of curiosities. So one, when you check a checkbox in HTML, what apparently gets set? On, O-N, or some non-null value. It's kind of arbitrary, but so be it. Dorm is interesting. It was a select menu, but it has brackets for some reason. Why might that be? What's that? Yeah, so this is, frankly, an idiotic design decision on PHP's part. So if you want to submit a form, well, in fairness, they didn't quite see perhaps where things were going, but it's become a headache. With PHP, if you want to submit a form field that's meant to be multi-valued, and therefore, when it's received by the server, you don't want to be handed one of those values. You want to be handed maybe an array of those values. You have to hint to PHP that this is a multi-valued parameter, and the means by which you do that is literally call your form element in your HTML foo, open bracket, close bracket. And that's just a clue to the server, to php.exe, that it should process this form submission, but then bundle up the multiple answers into an array and then hand them to you. So I say this is a very unfortunate design decision because this breaks things when we get to JavaScript and Ajax, when you actually need to address the names of these variables and you have weird syntax like square braces, which frankly could have been avoided by any number of mechanisms. But FYI, this is kind of what we're stuck with for now. There are ways around it, but if you ever need to accept multiple values, you can in that way. Now, does it make sense in this context? Well, I presumably only live in one place, but just for demonstration's sake, if I've actually not gotten along with many of my roommates, I might have, in fact, moved around. So now I've selected 4 values. Let's instead submit these 4, and you indeed see that on the server side, inside of that super global called $_post here, I get all of those form fields, as we saw going across the wire, but then dorm is actually an array. And we'll see how to traverse this array in PHP syntax. But the takeaway is what's really nice about PHP, unlike the years of Perl and CGI web-based development, PHP just comes with so much more built in for you that you just get handed on a platter, so to speak, just what the data you care about. You don't have to pre-process things. You don't have to include special libraries. PHP is really designed with this web-based interaction in mind. So let's actually print something more interesting out. Let me go back and let me go to a slight variant of this, my second version. This time it's going to go to frosh.ims2.php. And let me go ahead and open up this file here, frosh.ims2.php. OK, so now I got finally a little more, put a little more effort into this. It's an actual web page. And it looks like, I can kind of infer from this, this resulting page is going to say, thanks for registering so-and-so. Your gender is such and such. And then there's some if conditions here. So here's some basic building blocks of PHP to now get us into the habit of actually writing some logical code, some conditional code. So most of this is HTML, but every time I drop into PHP mode, it's going to do some interpretation. Now, we haven't seen this syntax yet, but you can probably guess. What does it mean if you do bracket, question mark, equal sign, back to back like that, probably? Yeah, put the contents of the variable there. So that equal sign is shorthand notation for the print function, or an equivalent, really, the echo function, which just echoes the contents of a variable. This is just kind of nice, and it speaks to, again, the pretty clean integration with HTML. You can just say, put this value here, called name, whatever the user typed in. Now here I'm doing the same thing for gender, because I sent M or F. I didn't just send a checkbox on or off. So it makes sense that I can print the value here. But here I have to do something different. So if the user checked that box, the value on is going to be sent. But notice what happens if I don't check that box. Let me go back to the browser. Let me again register as David with my email. I'm not going to be a captain this time. I'm going to live here. Register. Now notice, oops, got to reload so we see it. Notice what went across the wire here. Let me zoom in on Firebug. Go to params. What did not get sent this time? Captain. So presumably for performance reasons, if a checkbox wasn't sent, it doesn't even inform the server that that checkbox even existed. So that's a nice enhancement, but fast forward mentally to some use cases, it seems that if checkboxes are only sent when they are checked, this means you cannot safely iterate over the checkboxes that were submitted in order to see if someone has unchecked something necessarily. You instead have to iterate server-side over what you expect to receive. That didn't quite make sense yet. That's fine. We'll trip over it before long. But trusting user input, trusting browser input is never a good idea. And here's one hint of that. It's not, sometimes might not even send everything I'm expecting. So let's go ahead and actually register as a captain this time and see what happens. All right, captain, yes. And we've done that conditionally. Well, how did we go about doing that? Well, there's this function in PHP called ifIsSet. And it says if this variable is set, then it evaluates true, so print yes. So here I am making a safe assumption. Browsers, contrary to what you might think, don't send quote-unquote off. They send nothing or they send on. So it is equivalent to checking if this is set and whether or not I am a captain. I can just do that simple check because it's, again, not going to send a value like OFF, which would also evaluate to true because it's non-zero. So that conditional is OK. But notice what happens if I instead do something more familiar in most programming languages. If I just want to check if some variable is non-null, non-empty, then often I would just treat it as a Boolean. And I would just put it in parentheses and say, if this value is non-zero, do this, else do something else. But I'm not using the isSet function now. So let me go ahead and save this. And then we go ahead and reload. So that's OK, because I am a captain. But let's change to non-captain status, register. And now you see this. And you can actually see this in various Google results when people make mistakes in their web pages and then Google notices and the whole world knows about it. But you'll very often see this in your own code, perhaps, at least early on. PHP has different levels of error handling. So some languages also have this, but PHP starts with notices. A notice is kind of a small error that you should really fix this because you're really not adhering to the spec 100%. But this is not a deal breaker. Your code's still going to work, so I'm going to keep executing it anyway. So it says it more succinctly, notice, but that's what a notice actually is. A warning is a little more severe. A warning is you really don't know what you're doing, but you know enough to do some damage, so I'm going to let you do this just fine, and I'm going to print out this error message. But this is worse. You really need to rethink what's going on. An error is you're an idiot. So this code is just not going to compile. It's not going to execute. And you would see error on the screen. And the program's execution would stop prematurely. So this is kind of annoying, though, the notice one. And I've turned these on explicitly. And we've done this on the server explicitly. You can turn on different levels of reporting in PHP. And actually, don't remember that comment the first time you get an error in your PHP code. I'm talking about myself, let's say. So there's different levels of error reporting, and you can control them, either at this web server level, in the php.ini file, or even in your own code. What we do on the server is, for pedagogical reasons, we actually turn on notices, turn on warnings, turn on errors, so that the server does yell at you as much as possible to really push you to get your code rigorously checked. This is why, in this case, though, the user is also seeing these errors. Really, this doesn't feel like the best practice. I'm the developer. Let me know. Send me an email. Put an error message in the log. I don't need to be telling the user that I'm making these mistakes. And that's also a potential security risk. In general, telling the user that there's a problem with your code just invites trouble. So for development purposes, I'll often put this one-liner or two-liners atop my code, or at least in one file, that says, show me everything, because I don't want to constantly check the logs. Just show me when there's a problem. But you turn those off then when it comes time for production. So error reporting is set to a constant value, which means all such errors. Show me them all, including notices and warnings. Display errors means don't just log them, send them to the browser too. But that's a development trick. Now, why is this actually happening? Well, the notice specifically is this: undefined index, captain. Now, an index is a key into an array. So if it's undefined, that means that what does not apparently exist inside $_get. So that's the captain key. There is no variable, but that's consistent with the browser's behavior. It doesn't send the captain form field if it wasn't actually checked, and yet here I am blindly just checking that isn't in fact there. So there's two solutions. One solution is the one we had there in advance. Personally, I find this unfortunately verbose, especially if you're doing this constantly, which is very often the case in web programming, checking this form field, this one, and this one. It really doesn't lend itself to readability or sort of pretty style, I would say. But, and this one, here's where you can start to do some damage if you don't quite appreciate what you're doing. PHP supports an @ sign, which is a notice, a warning, which is a warning, error, and notice suppression operator, which says even if this line of code might trigger any one of those 3 failure cases, keep it quiet. Either because I don't want to see it or because I know what I'm doing. And in this case, and you'll see this even in my own code, if you know what you're doing and you are leveraging some basic understanding of what the browser is sending and when it might send that, and you want to be able to have fairly shorthand notation but want to suppress notices even when they're on, it's a reasonable design decision. This is not an appropriate solution if you're sitting there late at night for either the course or future life and you keep hitting some bug or some error condition. You don't know what it is, so you whip out the suppression operator. Like, not a solution. So again, use this with great care. But it's a useful way of just tightening up the aesthetics of your code potentially. If you're shipping code that's going to be used in libraries or for other people, frankly, go with version 1 and really be pedantic about it. Yeah?
What's the colon in the statement?
Good question. So there's a couple of ways you can implement conditional constructs when you drop in and out of PHP mode, which is happening here. So notice in this line, I'm in PHP mode because of this open bracket question mark and the opposite. But then I drop back to HTML mode. Then I drop back into it. So the colon is necessary in this case because it tells PHP you're about to exit PHP mode, but stay conceptually within this branch until you see the closing mark, which is an endif in this case. Another way of doing this, just so you've seen the syntax, although this isn't as readable, I would argue, depending on how many lines of code you're writing especially, you could do this, and then you could do this. So this is getting a little messy, I think, at least in PHP syntax, but this too would accomplish the same thing. Use curly braces so long as you open and close them. And just to be clear, let me do a third variant altogether, and we'll see other sort of approaches over time. Let me go back to the original. This feels a little messy in that I'm in PHP mode, then I'm out of PHP mode, then I'm in PHP mode. Why don't I just stay there? Well, you can do that. Let me go ahead and just change this approach. I'm going to just move this down to another line for a moment. I'm going to indent this just to be a little nitpicky. I'm going to stay in PHP mode. And you know what? I know I can print stuff out. Why don't I just do print this, and now I can drop out of PHP mode over here, so this would be another approach altogether. Now, this is where things can get arguably, a little messy. I mean, frankly, this is where people start to cringe with languages like PHP. If you're constantly calling echo or print pretty much equivalent functions to generate strings dynamically for a few reasons. One, you're incurring the cost of a function call, which does have some computational cost just to print out a static string in this case. Two, you're commingling what people generally call business logic with markup or structure of a page, which is often frowned upon. So it's one of these things where we'll see a lot of different approaches to code over time, and you'll explore various ones during the projects, but realize there are several different ways to implement these things. You'll see different things in the book and sections and lectures, but just tonight we've begun to scratch the surface. So with that said, why don't we officially adjourn? I'll stick around for questions. Alex will be starting section, if you're able to stay, across the hallway in 102 in just a bit. Otherwise, we will see you next week, and keep an eye out on the course's website for a PDF of Project Zero.